Ding, 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 ding. Alarm bell ring off there, right? So it's time to get going. It's time for me to mash up this maths. We're going to do some matrices today. So here's what I need everyone to do. I need you to take a screenshot of this and say, studying. I don't know. Study with Springs. Study session with Mr. Springer. Something. I don't know what to do. A nice screenshot, I could post the picture right here. So maybe I should point my name. And let me get ready to go. So let's see how many people do we have here. I'm seeing 67. That's good. That's good. That's a good start. I'll remember that number, 67 people on live. This is the student channel. So I'm just showing this channel some love. I normally do my stuff on Kerwin Springer channel. Don't worry, I didn't lose my password or anything. I know I didn't post there in a while, but it's coming. It's coming. So share it up, press like, everything. What we are going to study today, we're going to get really serious about some vectors and matrices. Not just matrices, matrix transformation. To be specific, matrix transformation. So on the screen, you should be seeing my notes. We have like 24 pages of notes you can get through here. So we'll see how much of that we can do. So just a big free session. Free up yourself, press like, share, and let's get started, right? So Student Hub channel, showing it some love. Maybe I should have streamed to both channels. Let's just keep it on the Student Hub channel for now. Let's freeze this as well. And let's get ready to go. So what vectors is, I want everyone to remember, and hello to those watching in the future, is that the key to vectors, one of the most important key is finding another way. So I was doing vectors with a lot of my classes this week, finding another way. So let me just show you all a quick thing for those of you all who brand new in vectors. Where are you? What position are you at in vectors? Shout out to those of you all from the Student Hub. If you're from the Student Hub, say me. Let's just see if we have like 1, 2, 3, 4. Let's just do some quick ideas. 1, I'm using uneven scales here. 2, 3, 4. Let's say I have this point over there, and I want to go to this point up here. So this point is 4. Maybe say let's make it higher. Let's say I have this point over up here, up there, right? And let's send this one down. Let's send this one down to like about this one. So do you know the coordinates of the sound of the points? Do you know to find the coordinates of the points? Like if I said this is point A and this is point B, do you know how to do that? What is the coordinate of point A and point B? We have 1, 4. What is the coordinate of point B? B is 4, 2. You understand that? 4, 2. So the vector, the position vector, which is actually the easiest question you could get in CSEC maths, is O to A. And what I'm telling you, everybody, look at this. We're going to see a lot of this. We're jumping into some past papers just now. Just give me a little 5 minutes for the introduction. OA is like if I started on the origin, easiest question in CSEC. The origin is the 0, 0 marker right here. Right? This is the point 0, 0. And I went straight up to A. Now, vectors tell me how much I go across. 1. How much do I go up? 1, 2, 3, 4. Understood? So I went across 1, went up 4, 1, 4, 1, 4. It's the same as the point. That's what I'm showing you. You all understand that? If you understand that right, I understand. So OA, the position vector, is the same as the coordinates. It's just that you have to write it in a vertical format. So what do you think the vector OB is going to be? What is vector OB going to be? OB is obviously, OB for obvious, going to be 4, 2. Everybody understand that? We're learning. Now, those are called position vectors. Vectors that start at O, the origin, are called what? Position vectors. Learn this like if the exam is next week. Learn this like if the exam is tomorrow, right? So, position vectors. Why is somebody from Guyana is messaging me right now? Just give me a second. Yes, it's live right now. Or maybe they didn't get the link. Let me just share the link with this person then. Jump in. Yeah, so it's called position vectors, ladies and gentlemen. These things are called position vectors. These OA, OB. Now, what about if I said AB? AB is not a position vector because it did not start at the origin. It's just what we call a displacement vector. All vectors that you deal with at this level, they'll be using displacement as the vector. So like changing position, displacement vectors. But AB can be figured out. Think about it. Check how much numbers it went across. 1, 2, 3. Seeing that? 3 across. So I'm going to put 3 at the top of the brackets here. That tells me I went across 3. And I have to go down. How much? What's the numbers on this side? 1, 2. From 4 to 2. I have to go down 2. You all understand that? So this vector is 3, negative 2. Because if you go down, it's negative. If you go to the left, it's negative. Now watch the scale. The scale is a little weird here, right, Jono? So it's actually 3, negative 2. So, all right. But we can also figure out AB by using something called the triangle law. And the triangle law is written like this. It's based off of the key to vectors and finding another way. The key to vectors is finding another way. OB minus OA. OB is 4, 2. OA is 1, 4. Now, I really should take 2 hours and teach this topic. I'm just showing you the formula and show you how we come about it. But if you search up Kerwin Springer vectors, you'll see a lot of stuff on that. So you can go and watch over how that OB-OA come across, right? 4 minus 1 is 3, and 2 minus 4 is negative 2. Ladies and gentlemen of the jury, do we not see that it's the same thing? So you can use the formula, and you can use just common sense counting. So that's a quick synopsis on where we are at in vectors. And then there is vectors using geometry and algebra, and we'll see some of that. So let's just jump in, brave. Let's just jump straight into the workshop on vectors where we'll do a bunch of past paper questions. So in the good year of our Lord, 2010, January, question 13, maths doesn't go up to 13 anymore, it only goes up to 10. There was this figure that was drawn, points were given, and we need to express in the form AB, the vectors OB. Ladies and gentlemen, OB is what type of vector? Anytime you see a O, what type of vector is that? It's starts with P. And how do we form that type of vectors? Thank you, Mr. Jono. It's a position vectors, Mr. Jiram, Kates, Maya, Shalisa. Position vector. How do we form the position vector? If we have the coordinates, you just write it in vertical format. So OB is -1, 4. And let's work out OA, OB one time. Now, I think I did this in class. OA is 5, 0. OB is -1, 4. And if you want to add the two of them together, part B wants us to go ahead and add OA with OB. Let's add. I should have 5, 0 plus -1, 4 turns out to be 4, 4. Then they wanted us to get the midpoint of the line BA, AB. So this. Now, since I already know that's the vector 4, 4, I know it's going to be in the middle 2, 2, and it actually coincidentally will turn out to be the point 2, 2. But that's a coincidence. Let's see what happens here. So we have OB, we have OA, and we need to get the midpoint M. How do we do that? Well, this part is not so much vectors. This part is actually this formula. The only formula in CXC with a comma in it. What is this formula, class? Who can tell me what this formula is? It came from coordinate geometry. What does this formula do? Chat, we cooking? What does this formula do? This formula tells us, wait in fate, let's just say this is x1, y1, x2, y2. Yep, it's the midpoint. So we have Sandaya, Khalees, Kyle, Mark. It's me, Leah, right? Find the midpoint. And we're going to just substitute the values -1 plus 5 divided by 2 and 4 plus 0 divided by 2. So you'll end up with 4 divided by 2, comma, 4 divided by 2, and very quickly you'll end up with the midpoint is 2 in this case. Now, I know some of you all just divided this vector by 2, which gives you the vector b to the midpoint, which is a little risky. It doesn't always work out to give you the midpoint like that. Use the formula. So what y'all think? This came in 2010. Let's see what else we have. We cook in. 2010 part B went on to do some dramatic things. Look at this. What do you do when you see vectors questions like this? What do you do when you see these questions? HF. Well, this style of vectors, hey, Zach, what is he seeing? This style of vectors is, you can think of vectors as having 2 branches. I was telling my class this week. So vectors, when you're studying, this is you, and you are so ready for the exam. Matter of fact, you want them to bring the exam tomorrow, right? Right? Anyhow, so when you're studying vectors, think of it in 2 branches. You can get this kind of AB style vector with this 2, 3, that kind of format, and you'll see lots of points, maybe, or they'll tell you a point is this and a point is that. Or you can get geometry and algebra, where they tell you like this, they won't put so much arrows, they might just put like this arrow here and this arrow here. This is U, this is V, this is P, Q, R, S. So this is vectors and geometry, vectors and algebra, and then they may ask you find QS, so you have to know it's backwards U, so it's -U plus V. This one, you use stuff like the triangle or thing. So 2 branches. So as you're storing vectors in your mind and returning back to your happy state, kind of, slightly worried, but as you're returning back to that state, store vectors in your mind like 2 things. Okay, it can come this way, it can come that way. It very rarely mixes. So you already begin to compartmentalize how you study this topic, right? So you notice they did that in the question, like they brought one with this style, the OBOA numbers vertical style, and then they're bringing this geometry, and instead of saying this vector is like 2, 1, they are giving it a letter name, V, common V. Do not mix up the common and the capital letters. Write that down. Write that down. People in my class was doing that. They know better than that now, right? So, for example, if I say what is the vector OE, don't come and tell me M. M is a point. Like if I ask you what is the distance between Port of Spain and Arima, and you tell me Tacarigua. You have to tell me the distance, right? So the vector is actually V. So OM is V. Maybe OM is V. M is the midpoint. So OE had to be 2V. All right, we are getting too excited. Let me do HF first. HF first. HF first class. All right, I think we're coming up with HF. So we definitely need to go and look at all them words they have up there. HF is the first question they want us to figure out. So we're going to have to look and read, and we love it in maths when we see a whole paragraph before a question. Best thing ever. OE. All of these are straight lines. That's there, so nothing new about that. EF is 3EH. I want to tell you here, ladies and gentlemen, you'll see by the time we have finished this workshop on vectors, there are 2 ways they can bring these ratios. This is one of them, where EF is 3EH. So make sure you follow the language properly. Watch the language. E to F, are you visualizing it? Where's my pointer? This is what I'm reading, right? E to F is 3 times the distance as E to H. So that means I can think of this as having a next spot here and I cut EF into 3. And if EH is U, then this is also U, this is also U. So what is HF? HF is not 3U. H starts here. What is HF? Can we see now that HF has to be 2U? Can you see it? If EH is U, and from E to F is 3 of that, then H to F must be 2U. Simple things. All right, let's go on to the next one. MF, M to F. Well, we already established earlier that ME is also V, because OM is half the way and ME will be V. Class, how are you feeling about that? You're feeling a nice warm fuzzy, I know this feeling in your heart. So what is ME? Please share the link in all your class groups. Tell them to jump on so you wouldn't feel alone studying with this man, a strange guy from Trinidad and Tobago. ME is V, but we need to get MF. The key to vectors is finding another way. I'm seeing the answer in the chat. Chat, big up you, cooking. I'll go and call some names just now. So MF is this. We don't know that. So Zach is here in the chat. I was saying this is like if we leave Zach's house and try to go to his bird's house. However, we do not want to cross this route yet. We don't know the way. There's a pit bull in the yard. So the key to vectors is finding another route. So to find the other route, we'll have to go to his next bird house first and then go to F bird house. So meaning, right, Zach? Meaning we go from M to E and then E to F. So you write that. You write MF is the same as M to E. And if it's a plus here, you usually start back with the same letter, E to F. Notice how this always happens. The two letters that you want come on the end, and this is like the connector. You understand? So M to E is V, and E to F is 3U. That's the answer. V plus 3U, and that is why Shreya, Neelish, and Makila, and John all had that answer. They saw it. All right, that's another one done. Are you feeling like you're gaining the knowledge here? The knowledge points is adding up. OH, OH. So now we need to find O. We have A, B, C. Part C is what we are on to. O to H, very simple as well. We wish this could come for our exam because they're looking straightforward. O to H, once again, we do not know the route for O to H yet. We don't know how much V's or U's involved in that. But we can find the other way, which is going from O to E, Zach Birdhouse, and then go to the H. How much birds Zach really have? One bird, one bird, one bird. It's just kidding. Eh? O to E, and then E to H is what we'll use. And O to E is 2V, and E to H is just 1U, 2V plus U. Reach out to 10, how much you understand everything so far? Only 17 minutes has passed, and I'm sure some of you deep down inside the vectors already. New revelation from hopefully the 317 of you all that share live. 2V plus U, so that's good, that's good. Show, and that's it. You stop right there. Don't feel you need to go and get a number like 2, 3. No, stop right there. Right in terms of U and V. Show that OG, the OGs, big up all the OGs one time. Show that OG is 3/5 of 2V plus U. How do we do that? Firstly, they want us to find OG and show that is 2/5 of the way. So this is looking real interesting. So we go up to the question and see if there's some other information that we may have left out, you know, right there. Ta-da. So that MF is 5 times the distance of MG. M to F, 5 times MG. Hold up. That's it. That's good because I know what MF is. Class, we worked out MF. It's right here. Let's put that in a box. It looks important. So MF is 5 times MG. They gave us that for a reason, and here's the reason. We're trying to get OG. If I can get MG, I already know OM. So I'll combine OM and MG together to get OG. How many of you all seeing the vision? Are you seeing the vision? So now our only goal is to get MG, and then we go forward. So MG is actually 1/5. If I reverse it, MG is 1/5 of the way MF is. See now, because MG is, if I multiply MG by 5, I'll reach the F. That's what they're saying. MF is 5 MG. So in reverse, MG is 1/5 of MF. which means it's 1/5 of V plus 3U. Don't while it up yet, tell you. Don't while it up yet. Don't while it up yet. Trust me. Just leave it. By while it up, I mean, for those of y'all who are not from the Caribbean, I mean, don't distribute it. Distributing in the math textbook is called whiling it up. Don't while it up. So leave that just so, because we just figured out MG. Now we're just going to add OM first. We're going to say that OG that we want to show is actually OM plus MG. And we're hoping for the best here. We're hoping that, you know, the maths is forever in our favor. The V, OM can be replaced by V plus 1/5 of V plus 3U. Take your time, take your time. Don't rush it. 1/5 of V plus V. Isn't that supposed to be 6/5 V? How many of you all know how to add fractions in your mind like that? 1 of something plus 1/5 of something is 1 1/5, which is like 5/5 plus 1/5, so 6/5. You can use your calculator to add 1 and 1/5. And then there's a 3U here. Okay, so we show this is OG. What they are telling us, OG should look like 3/5 of 2V plus U. This is popular with vectors. So you find something, but they have it slightly different. Can you see these similarities? What must be factorized out to just reach the last line? Of course, 3/5. 3/5 times 2 is 6/5, so that's 2V. 3/5. What I need to do here, divided by a whole fifth. 3/5 times, hold on, something is suspicious. Oh, I leave out the fifth here. I left out the fifth. This is 1/5 of that and 1/5 of that. So I have 3/5 here. So since I already have the 3/5, just put back the U. So I left out the 3/5 right here. You see that? 1/5 by 3. And that's how they got the 3/5 there. So we just finished. This is as difficult as these vectors questions can come. What do you see? What do you see? What do you think? Rate out of 10. The main thing is understanding that the key to vectors is finding another way and then understanding how to manipulate the fractions properly. So if I guarantee you, if this was just like a V and another V here, and I say OG is V plus V, 2V, everybody that'd be, yeah, I understand. But anybody who don't understand is because they'll get lost with the fractions, which is why we have to do another one. Let's go. Now, this is all the solutions typed up here. Those of you all in the Student Hub classes, why is in the chat if you're in Student Hub classes? We have a lot of Student Hub students here. We will send, or if you're in the crash course, we will send you this, right? We'll send you this typed up. 2010 June, the good year of our Lord, 2010 June, question 11b. Here we have another vectors. And in this, it looks like it's going to be the geometry style vectors. Notice how there's a geometrical shape. We have U, we have V, and we have some other information there. We need to copy the diagram and show the points M and N. So let's see if we can figure out those M and N points. Listen to me. You need to be very careful with this. Those of you all who are getting good in vectors, do not get overconfident. There are many ways you can write this that throw you off. Think about each thing. Don't just jump into the question. JM is 1/3 of JK. Straightforward. There's a new point M and N on JK and JL respectively, such that J to M is 1/3 of JK. Visualize where that point will be. Tell me if you were thinking this. Were you thinking that? Yeah? JM is 1/3 of JK. J to N is also 1/3 of JL. Fascinating. So we're going to put the N there. 2 marks. Now they don't give away marks, so CXC maths is one of the most stingy, is the most stingy exam in the whole of CXC for maths. No other subject more stingy for maths. Given that JM is U, so they said J to M now. Let's just make a tiny highlight so you see what I'm talking about. J to M is U and J to N is V. So here we go. This is U and this is V. And we need to find some stuff regarding that. Write in terms of U and V an expression for JK. Not a problem. Not a problem. JK is 3 times JM. And since JM is U, JK is 3U. Done. MN. So you might be thinking, what to put for MN, boy? What to put for MN? What to do? Well, the key to vectors is, I need somebody to say it. The key to vectors is, what is the key to vectors? Now, there's a delay when I ask this question, right? Finding another way. Yes, the key to vectors is finding another way. Yes, the crash course for math starts next week, Monday. The key to vectors is finding, this is just extra sessions that the crash course people get in, and I'm opening it up to everybody online. So, key to vectors is finding another way. If you're interested in signing up for the crash course, by the way, +1 868-310-1306. There are lots of students in the crash course. The maths crash course has been packed. Ram. +1 868-310-1306. You WhatsApp that number and you can get you, right? Anyhow, I forget what I was doing. MN, key to vectors is finding another way. So I can't go directly from M to N because I don't know what trap is that. However, I can go down from M to G, see not everybody, and then pick back up on G and go to what? N, and that's Mn. Now, Mj is not U. Mj is negative U. Why? Because Jm is U. Mj is backwards. Understanding how the negatives get it play now? Jn is positive, so we put plus V. Proper things. So we get the next one. C, KL. KL should technically just be this multiplied by 3 because we're seeing that this is a ratio and this is 1/3 of the way. But fine, let's pretend like we didn't know. KL is the same as K to J plus J to L. K to J is negative 3U's because remember this is a U and this is a U. So I need to go backwards on all these U's. That's negative 3U plus forward 3V's. Seeing it? Very straightforward, right? So this is KL, max. Using your findings, and this is what I was telling you in class, those of you all from class. Deduce 2 geometrical relationships between Mn and KL. What are the 2 relationships between Mn and KL? Chat, let me know. Mn, KL, what are their relationships? Geometrically. Parallel, lovely. So KL is parallel or vice versa to Mn, and we can know this since KL is actually just 3 times Mn. Anytime a vector is related to another vector by a scalar factor number, it's parallel. KL is simply 3 times Mn. That means it's parallel. You might be thinking, oh, there's a by the way information, though. That is come real plenty. A vector is parallel to another vector. If you could factorize out a number out of it, we call it the scalar factor. Okay, that's one. What's the other relationship? Scale factor of 3. That's the other relationship. Mn is actually 1/3 of KL. I could write it the other way around. KL is 3Mn. So KL is 3 times Mn. So it's an enlargement of Mn. So one is that it's parallel and the next one is that it's 3 times. There we go. I see some people say collinear. Chat, is Mn and KL collinear? Are they collinear? Mn and KL, are they collinear? What does the word collinear mean? Somebody probably know that that word shows up in vectors as well. Ladies and gentlemen, these things are not collinear. What does collinear mean? Collinear means lies on the same line. For something to be collinear, it needs to be on the same line. For example, PQR. PQR are collinear. They lie on the same straight line. We'll see it. There'll be a question on that soon. So there's the solutions. We'll send the solutions to you guys from class. OP and OR are position vectors. Another one. So switching over, coming up a year. Wait, now we're going in order. January 2011. Question 11b. PS is the 0.27 and PR is equal to 4, -3. Write in the form AB the vectors OP, OR. A point S has coordinates 14, -2. Find RS. And there's that word. Show that PRS are collinear. Beautiful, beautiful. What a beautiful question, don't you think? So is this, what version of vectors is this? Is this the geometric version or is this the coordinate geometry points version? Which version of vectors is this? Abigail's asked her how long this is. I have no idea. This could be real long. We could finish 12 o'clock, all kind of thing. Whatever. Maths exam is next few weeks. We can finish 12 minutes. This is the coordinate geometry types of vectors. Because I'm not seeing anything drawn. I'm not seeing like U and V's and those things. No, it's not algebra geometry. It's coordinate. So OP, for those of y'all who just came in, if they give you up, I need you all to understand this is the easiest question for CXC. If they give you a point P is 27, what is OP? Folks, just take the 27 and write it like this. Even if you don't understand vectors, you can get that one. You can get that 1 mark. You can get that 1 mark. What is OR then? Well, we don't have R. We don't have R, but we do have PR. So we're going to make use of what I introduced earlier called the triangle law. The triangle law looks like this. AB would always be equal to OB. You notice how the B comes first? OB. You notice how this is a normal displacement vector. This is a position vector. Minus what? OA. This triangle law is powerful because it links position vectors to displacement vectors. So in this case, what is missing? I'm missing a position vector, but I have the related position and displacement vector. So I can write that PR should be equal to OR, and notice how the second one comes first, minus OP. Chances of you using this formula in the exam is very high. Learn it. This is the triangle law. If you look up on YouTube, Kerwin Springer Vectors, you'll see on my channel I have a complete breakdown of this. I cut out paper and show you how this come about. So if you want to have a deeper understanding of it. OR, ladies and gentlemen, is what we're trying to find. So let's do a little rearrangement here. We can rearrange this and get OR, leave that there, bring across the OP. OR is really OP, it will turn positive, right? Plus PR. Now this is also the key to vectors, is finding another way. O to R would be the same as go from O to P, add, resume back on the P, and go to R. Some people understand this, they may be able to start with just this. So therefore, OR is equal to, I'm just rewriting it, OP plus PR, which we already know. OP is 27 plus PR is 4, -3. This turns out to be 2 plus 4 is 6, 7 minus 3 is 4. 6, 4 is the answer. Rate out of 10, how much you'll understand that? We cooking? Chat, are we cooking? So don't go to 12, are they saying? Don't go to 12. All right, they're saying don't go to 12, chat. Now, there's this point S, and this is continuing, that has the coordinates 14, -2. Find R to S. Now, listen to me. Listen, lock back in. That is Coffee Zach. Anytime they give you a point and its coordinates, what have they also given you? In vectors, if they give you a point and its coordinates, what have they also given you? They have also given you the position vector for that letter. S is 14 negative 2. So OS is, why Ashley asking me to do it in the crash course? I'm doing it right here, right now. Just locking right now. Just locking right now. In the crash course, we do all the topics, but we do it from a past paper point of view. It's not like in the crash course, I'm going to teach you 2 hours of each topic. That's the whole year. You understand? In the crash course, we go through at a rapid speed every topic from a past paper point of view. So OS, for those of y'all, most of y'all, rate out of 10, how much y'all understand this? When I did that just now, most of y'all pretty high up, but there are a couple of y'all I've seen y'all type in here. Y'all may need a deeper breakdown, like maybe you don't understand coordinates too well, maybe you don't understand position vectors, maybe you need to go into vectors deeper. It is right here on YouTube. Just search vectors, Kerwin, Springer, and self-study, autodidact for yourself, right? All right, so OS is 14 negative 2. Lock in, 14 negative 2. Stay locked in. If they give you a S, a point S, the position vector OS just means change this around. Just to quickly pound this in, because it's probably waiting for you in your exam. If they give you a point, and they say this point is 3, 2, and that is point T, then the position vector OT means go across 3, go up 2. That's why OT will be 3, 2. All right. There's nothing to understand there. Just follow my words, right? There's something to understand, but it's simple. Find RS. So RS, I am feeling to use the what law? What did I call the law? What did I name the law? The law that said AB is equal to OB minus OA. What is that law called again? Because I see I have OS. And do I have OR? Yeah, I just figured out OR. That's what I did. I have OR. So that's the triangle law. So RS is OS minus OR. OS, and now I substituted it and just mash up the dance. 14 negative 2, OR was found to be 6, 4. 14 minus 6 is 8. And negative 2 minus 4 is negative 6. Now, if you're struggling to understand directed numbers and things, you'd also have problems with this, which means you have to go back and refresh directed numbers, meaning how to add and subtract negative numbers. Understood? Now, they finish off with this. Show that PRS are collinear. I need everybody to lock in. Lock back in fully. Some of you all, this was super easy, but this is the part you're interested in. Collinear. How to collect this in the exam, my brother? How do we collect these collinear marks in the exam? When they say show that something is collinear, what do? We're excited to see what's going on here. Well, first, let's go check out the points P, R, and S, right? So what do we know about P? We know P is 2, 7. We know R. We don't know R. Well, we know OR, so R has to be 6, 4. And not that I need to write this, I'm just showing you. It's very simple, but I'm just kind of letting you get find your bearings now. S is, that was just given, 14, negative 2. So we need to show that it lies on the same line. I need you all to have a complete understanding of what they're trying to ask here. So let me drop a graph, but I'm not going to draw the graph. I'm going to pull up something online, and I'm going to show you the graph. I want you all to get a deep understanding of what's happening here. Hang in there. No, don't hang anyway. Don't scratch that. Don't hang anyway. Just sit tight. Sit tight is a better way to say this to exam students. Yeah, anybody any wrong ideas here? So what I'm doing is I'm bringing up the graph in the background. I just study see that. Oh yes, what country are you from? Shout out your country in the chat. All right, so let's see my little graphs today. So I want to plot the point P. Let me see if it'll do that. 2, 7. Give me something. Nothing, right? What to plot a point on this most way? Label. Look at there. Oh, cool. That real bad dog. P. P. Nice P there. 2, 7. That's the first time I do that in life. And what's the next point? I get too excited here. 2, 7. R is 6, 4. So again, first hand understanding of what's happening is 6, 4. You see where R is, everybody? Are you watching this on what? I hope you're watching this on your TV, eh? I hope you're plugging on HDMI cord and taking this in 3D. 14 negative 2 is the next point. 14 negative 2. Maybe you're already beginning to see what's happening here. This is point S. Watch this, watch this. Now you understand what collinear means? If I were to draw a straight line, do you see that I will connect all the points? But how do we show this? We can't pull out decimals and draw and tell them watch, look, looking like it's on a straight line there. How do we show that collinear business? Here it is. And collinear means lies on the straight line. And if I draw a straight line there, it's true. It does. It does indeed lie on the straight line. So how do we show this? Well, you use vectors connecting the points. So we check and see if you have PR or PS or RS or SR. Check and see what vectors we have. I had just skip a beat there. Come on, don't do me that. RS. So we have RS here. Yeah, we do have RS. We have R connected to S. So now I'm trying to find something involving P. RS, I want something involving P. Do we have anything involving P? Yes, we were given PR. Class, you all with me? So I am seeing that I have PR and RS. This is RS here. Let's write it. PR is 4, negative 3. Now, it's very easy what you have to do, but I'm showing you it from a nice first principle. So I'm showing all the graph and everything. 8, negative 6. You can already see you've seen some ideas happening here, class. Watch this. 4, negative 3, 8, negative 6. Maybe you've seen something already. Now let's go back to the graph. No, I have the graph here. PR, what they're saying is that PR means go across 4, that's correct. And go down, how much? 3. That's why it's 4, negative 3. Everything making sense? And RS is go across 8, go down 6. RS 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. What do we know that make vectors parallel? You see, vectors tell us how much to go across, left or right, and how much to go up or down, vertical. So if the vector has the same ratio, that means they are parallel. If a vector says to go across 2, then go up 4, and this vector says to go across 4, then go up 8, both of these will make parallel lines. Do you understand what I'm saying? Because it's the same ratio, which is where the whole scalar factor thing comes from. Hopefully somebody getting a eureka moment across the Caribbean here. Please. So this is what makes these things parallel. So I could say, therefore, PR and RS are parallel. Why? Since I could find the scalar factor. RS is 2 times PR. Scalar factor of how much? In the tougher vector questions, they will give scalar factors like fractions. In this, we could clearly see it's 2 times. So since they're related by a scalar factor, I could just multiply this by 2 to get there. That always means they will be parallel. Always. But there's something extra. We would only get 1 mark. This is actually saying that they are collinear. We only show that they are parallel, meaning they run the same direction. But collinear means they actually line up and on the same line. Well, it's very simple to show that they're on the same line. Why are they on the same line? They share a common point. If something is parallel and it shares a common point, in this case, the point is R, therefore, they are also collinear. You understand? So, to show that they are parallel, get the scalar factor, show that one is a product or scalar multiple of the other. You have to find the scalar factor. To show that they are collinear, you need to show that they share a common point. Let's do this. Let's do an example. Maybe some of you all, that was too much. That was intense. Break it down. All right, well, let's just do something real simple, right? Everybody lock in. I'm going to break it down. Let's just watch this graph. We'll just make up 2 simple vectors that will be parallel, right? And it's a really nice, neat, simple idea that they really like to bring. So what I'm doing is just drawing my y-axis here. 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4. You'll have to help me here. 5, 6, 7, 8. What about if I have this here, this point from like maybe 2 to 4. Let's say 2 to 3. Let's keep it 1, this to this. And I want the vector to actually go in this direction instead. Tell me, what is the vector in terms of like if I call this point P and this point Q? What is the vector? PQ is what? So I all right coming up with that. I'll put 2 other points now. Maybe I'll put a point quite over here. And then I'll put a point up here. So I'm going to call this RS. What is RS? What is PQ? Nobody can tell me what PQ is yet. And what is RS? No correct answers for PQ yet. What's going on here? Still no correct answers for PQ. Still no correct answers for PQ. Finally, Kyle, come to the front of the class. PQ means go back 1, go up 2. If you're going backwards, it's negative 2. Wiley's getting that wrong. If you want to use the triangle, I use the OP and the OQ, and you can figure it out that way too. Maybe you all did that. Maybe you're just doing the whole long thing. OQ minus OP. Just to quickly show you the triangle out. OQ, this is the point 1, 3. So you'll put 1, 3 here minus P. P is the point 2, 1. So you put 2, 1 here. 1 minus 2 is negative 1. 3 minus 1 is 2. So you get the same negative 1, 2. Check yourself before you wreck yourself. What is RS now? What is RS? Oh, you mean you thought I say QP and I write PQ here, right? Anyhow, where's RS? RS is negative 2, 4. Can you see the similarity? Can you see the similarity? Can you see that RS is simply 2 times PQ? And can you also see that because of that it's parallel? Now you understand what I mean? Even if I extended this, and instead of having S, what about if I had a T up here. A little T up here, so right up in the Japanese up there. T. What is RT now? RT is go backward 3, go up 6. Can you see that all of these vectors are parallel to each other? Why are they parallel? They're related by the same scalar factor. They have like, it's almost like, you could think of it like a fraction and you could reduce. 2 into this is -1, 2 into this is 2, which is PQ. It makes it parallel because it means you are going via the same ratio in terms of horizontal versus vertical. It's almost like you have the same gradient then, change in y over change in x. How I get 6? 1, 2, 3, 4, 5. How much? 6. Let me know how I get 6. This number tells you how much you go up or down. Since it's positive, we're going up. Okay, let's keep going. This is where it gets really interesting. So to show that it's parallel, all you need to do is find the, like RT is actually 3 times PQ. You all understand this statement? And that means, therefore, parallel. That's it. Once you have shown that it has a scalar factor to the next one, it's parallel. Once you have shown that, and you see, you can use the word scalar factor. You'll see it in all my in the notes. The collinear part now, everybody lock in. P is PQ. We'll answer this question. Is PQ collinear with RS? Collinear means lies on the same line. Is PQ collinear with RS? No. Look, PQ over there and RS over there. They're not collinear. They're parallel, but they're not collinear. How about finding this vector here, ST? ST happens to be the same vector as PQ. If you look at it, ST is what? ST is -1, 2. That's the same, -1, 2 as PQ. It's the same size, same direction, so they're equal. And we can see that if we had the geometric shape, the parallelogram thing. Now, answer this question. Is RS collinear with ST? Is RS collinear with ST? How do we know? The answer is yes. How do we know they lie on the same line? Because they have a common point. Look, ST, RS, if they're parallel and they share in a common point, it must mean that they lie on the same line. Now for CXC, we have never seen them ask you to prove collinearity for vectors that are disjoint from each other, which would require you to do some deep coordinate geometry work. This is basic stuff here. You're just showing that they share a common point. And that's it. That's all you'll have to do for CXC. So let's keep treading this road, the straight and narrow, to overcome our pain and sorrow. All right, so WXYV is a parallelogram in which WV or VY is equal to A, VW is equal to B, S is a point on WY such that WS 2, SY is 1 to 2. This is the tricky one. This is press like. Press like on the video one time. This is the one people getting wrong all the time, boy. Was this thing floating in my coffee, boy? Yes. So write in terms of A and B an expression for WY. So you need to understand this carefully. Watch this. WS to SY is 1 to 2. Some people just run with the idea that S is in the midpoint or something like that, especially if they had 1 to 3 here, they might just say, well, this is third of the way. If you see 1 to 3 here, that means split it in 4 most likely. Yeah? Sometimes. Like in this situation, if this was 1 to 4, that means split it in 4. How much do you need to split this into when you see 1 to 2? How many parts? WS is 1 part. and SY is 2 parts. So in all, this represents 3 parts. Look at Tyrell now, boy. Look at Tyrell, boy. I don't know what to say. Imagine how childish you had to be to come on a maths video, hear people struggling with vectors already, and you like a little sniveling boy. I get to cuss. Nobody could know who is this. I could cuss. hey. Sometimes you need to check what it is you're really doing. You're losing. What do you call it these days? Aura points, boy. You're just losing your aura, and you don't even know you're losing your aura because you're coming on the internet and you see your anonymous, so you feel like I can write a rude word, and you write a rude word, and you what you watching it? Gosh, bro. On talk now. Talk to your brethren now. So WY is AB is 1 to 2. Right. So we're trying to work out WY here. VY is A, B. Hey, we had WY in the bag. Where's WY? WY is easy thing. Where's WY? The key to vectors is finding another root. WY just means go from W to Y. I don't know it yet, but I could go from W to V and then V to, see it? W to V, and then add up V to Y. W to V means minus V, B, and V to Y, A, and you're done there. Now, you could rearrange that, right? A plus A minus B, like swap it around. Don't switch each sign, keep the sign, and you'll be good. So what's next? WS. Well, WS is 1/3 of the way. WS is 1/3 of minus B plus A. No, you can stop right there. Or you can distribute, while it up 1/3 of minus B, so that's negative B, plus 1/3 of A. Or you can say B over 3 plus A over 3. Any one of these 3 things could work. Why isn't the chat for yes if you understand? SX, for SX, we want to do this. So how do we get that? Well, the key to vectors is finding another way. We already just figured out WS, so we know this way. We know WS. So if we know WS, we also know WX, because WX is the same thing as WY. Hear my words. WX is the same as, sorry, VY, A. You understand? It's a parallelogram. So this is A up here. And we just figured out that WS is 1/3 of negative B. I could write A minus B, and I could write it like this, as I tell you. 1/3 of A minus B. Now, everybody noticing where a couple of the people get lost all the time? Where they get lost? When we bring in fractions. It's not really the vectors is your weakness, is you need to stay focused so you can follow what happening with the fractions. Some people don't send in me the answer for the next one, which is correct. Zach, you really do that way, boy? That's an interesting way, but that's correct. Just a quick recap. Stay with me. Everybody was at the WY, and there's like, nah, WY real easy. WY is the first one we figured out, and that's minus B plus A. Or we can write this as A minus B. Everybody understood that. WY is this whole long thing here. And instead of doing WY, we went backwards on this. So that means it's minus B. We went forward on this, that means it's A. So minus B plus A is WY. WS, remember, that's 1/3 if we split it into 3 parts, because that's what is said up in the question here. WS to SY is 1 to 2. That's 3 parts. 1 part here and 2 parts there. So therefore, WS is 1/3 of WY, which we just figured out. So that's why I said WS is 1/3 of minus B plus A. That's it. That's it. Stop right there. Just allow your mind to accept that. 1/3 of the A minus B. I could write minus B plus A. I could just switch this around, put the A in front so the negative isn't like exposed out there. And then SX is the reverse of this. Because to go SX, I need to go the reverse. This is WS. So SX is really minus WS, the reverse. Correct? Plus WX. Or I can write this as SX means go from S to W and then go from W to X. Okay, SX means to go from S to W. S to W is not the same as WS. It's backwards, so that's why the negative sign come out. S to W is negative that. So since WS is 1/3 A plus B, S to W is negative 1/3 A plus B plus WX is A. And this is just to take it home with fractions here and you're good to go. Let's take it home. So we will resume up here. We have negative 1/3 A. And the negative will go and multiply by the B as well. So negative 1/3 B plus A. So this is really saying A minus 1/3 A, which is how much? 1 minus a third is 2/3 A minus 1/3 B. Another way to write this would be like 2A minus B, 1/3 of that. Or 2A minus B all over 3. Or any way you want to write it. But let's stop right there. Let's see where they want to take this. This is, you get full marks for that, right? All right, so R is the midpoint of VW. R is the midpoint of VW. Where's that? R is up here. Prove that RSX are collinear. So I'm going to speed through this one. Prove that RSX are collinear, meaning lie on the same line. You understand what they're asking now, right? We remember we spent a lot of time on that recently. So do we know SX? Yes. So the only thing I really need to do is get RS. Because remember, I need two vectors that use the 3 points. So I already have SX is this. Let me write this a little bigger in the corner here. SX is 2/3 A minus 1/3 B. And now I'm going to find RS, which is simple. RS is the same as going from R to W. Then I'll go from W to S. R to W is half of B. R to W, this whole thing is B. So R to W is half B. W to S, we already established that is 1/3 of A minus B. 1/3 of A minus 1/3 of B. That's when I distribute it. This is a half, by the way. I made a mistake. Half B. So half minus 1/3 is, you can double check it. A half minus 1/3 is how much? Half minus 1/3 is negative. Positive. Positive 1/6. So why don't I have a positive here? So I'm getting 1/6 here, which is correct. Let's just recap. Negative B plus A, so this is either A minus B. WS is 1/3 of A minus B. That's 1/3 of this, but it's actually, yeah, so 1/3 of A minus B. And SX, we use the negative. So we get negative 1/3 A minus 1/3 B plus A. So negative 1/3 minus 1/3 is negative 2/3 A minus 1/3 B. Actually, positive minus. So let me just make sure everything looking like everything here. I had a negative inside here that I left out. Negative, so this would be back positive. So I just left out that positive sign there. So it's positive 1, 2. I want to apologize for that. This sign was supposed to be negative from up here, and somehow when I was talking, I left it out. So this sign was supposed to be negative. That would make this positive. The reason I checked back for that is because I was seeing it down here while I was doing the question. I was getting positive 1.6 here, but I was seeing a negative here, so I just checked back. All right, so we're good. All is well with the will. No laws were broken. So, wanted A plus 1.6 B. Now, this is the I am saving the life. This is the one of the hardest it can come, because all the fractions, and you have to make sure you're keeping track of everything like that. Don't leave out any negative signs. Don't make any errors. So we still have to do this. The concept is still the same, no Aaron and everybody. To keep the Zia Ulex. To show that it's collinear, we need to show it parallel and share a common point. How we know it parallel? Can you see that Sx is actually 2 times Rs? Watch this and watch this. Can you see it? Let me help you see it. So if I rearrange Sx and I take out the 2, this is 2 into 1/3 A. If I take out 2 out of 1/3, it means divided 1/3 by 2, you'll get 1/6 B. So Sx is really 2 times this, which is Rs. So once you get that common scalar factor of 2, therefore Sx is parallel to Rs. So you get that first part, and then it shares the common point. What is the common point with these two vectors? Sx, Rs, S. Therefore, it is collinear. Got it? So this is as rough as these kind of vectors question come. And I think this is why some people rate this as one of the hardest questions when it starts to go into the fraction like this. But you just need to take your time and don't get distracted talking to people. So SW plus WX, that's how I got the SX. I substituted this stuff. So when you're watching it over, just pay attention to what I'm substituting from where and try to track all the fractions properly. Let's do another one. Now, all these solutions are here typed up really nicely. So you can go revise it, all of y'all in class. What type of question this looks like? Does it look like is this the coordinate geometry, or is this the just random shape geometry with U and V? This is the coordinate geometry, right? Because they're actually literally giving you some coordinate geometry points. And all of this is easy. I think I did this one in class. If I want OA, I just watch where A is, -1, 3. And this is going to be -1, 3. If I want OB, watch where B is, 5, 1, 5, 1. Back to the easy side of vectors. BA, this is the triangle, but I write it back to front. BA is the same as OA this time, because A is the second one, minus OB. So you just substitute 1 minus 3. Sorry, why did I switch the sides? -1, 3 minus 5, 1. 1. I short-circuited minus 5 minus 1 is minus 6. 3 minus 1 is 2. 6 come down 2. Correct. That's PE. Why isn't it chat if you understand? So I think you're hoping for something like this to show up and not too many hard fractions. But if you get the fractions, just take a deep breath and work through it slowly, double checking while you're working. Given that G is the midpoint of the line AB, write a column vector in the form XY. So we need to get G. Getting B to G is easy because I already have B to A. You go across, you go backwards 6, you go up 2. So if BG is G is the midpoint, BG must be equal to half of BA. We cooking. So that's half. Wait, nice. I seen primary school students here. Half of negative 6, 2. So this is negative 4, 1. So half of 6 is 3. Negative 3, 1. So you go backwards 3 and you go up 1 and you'll get G. So G should be more like here. So that's G. So we can figure out that G is the point 2, 2. OG. So I guess they want us to show working. So OG is the same as going from O to B and then from B to G. Remember, key to vectors another way. O and G, B is the middle. Joining the 2. Slow down. Oh, I started to pick up too much speed. Too much speed. Well, we do all of this already now. That's why I went through this in a slow-mo already. So I kind of go in exam space here. Too fast? Too fast? You all understand the OA, the OB, and the BA, right? BA is OA minus OB. OA, A was second, OB. All of that is good. And then we went on to find G, the midpoint. Instead of using the whole formula for the midpoint, since I'm seeing that I need to find BG, you all seeing what we want to find? We want to find B to G, eh? And what we just found B to A. B to G is halfway there. So that's why I said BG is half of BA, which I just found. So I just found half of this. Half of negative 6 is negative 3. Half of 2 is 1. Good? Everybody find back the way there? And then OG is that. That's what OG is. OG is like going from O to B, which I already know, because O to B, I don't have that. And then I go from B to G, which I just found. I just found B to G. So instead of saying OG, I write OG is equal to OB plus BG, and I just add the 2 together. OB is 5, 1, 5, 1, 5, 1. And I need to add what I just found, BG, negative 3, 1. So I get 2, 2. And when I look at G, I see it's on the point 2, 2 as well. So I'm pretty sure about that answer. So this is not bad. This is not bad. If you get something like this for the exam, you're cooking them. You're cooking them on slow. You're broiling them. All right, let's do another one. So after we finish this vectors workshop, we're going to just switch over into matrix transformation. Or you want to go one time, or you want a little mini break. The points A, B, and C have position vectors, bang, expressed in the form XY. So once again, triangular all the way, triangular all the way. BA is equal to, second one first, OA minus OB. So how usually triangular comes in? OA 6, 2 minus OB 3, 4. Now the reason I went fast is you get into C. This, right? This is really easy stuff. We just substituting. And BC would be what? BC would be OC minus OB. This is June 2012 now. This is really easy. If they bring this, they ain't gonna waste so much mark on easy thing like this now. Back in the days, they used to do these things. 6 minus 3 is 3. 2 minus 4 is negative 2. 12 minus 3 is 9. Negative 2 minus 4 is negative 6. Now I see in the pattern here. How many of you all seen there's a little relationship here? Seeing the 3 to the 9, the 2 to the 6. Seen it? Are we seeing it, class? What does that mean about those two guys? What does that mean about them? So somebody asks, why are you not adding? Why do you have this subtract sign here? That's how the triangle law works. There's a deeper reason for that. I'll tell you to go and check it out. Those of you all, the triangle law relates position vectors to displacement vectors. So like if I have AB, right? And I'm trying to get AB, but I don't know what it is. But I know what OA is and OB is, or R. AB is the same as if I go from A to O, right? A to O, add, see the add now? O to B. So where the minus come from? The minus realize that A to O, I really want O to A, but I had to go A to O. So how about we just switch around this O to A, and that means you're going backwards. And that's as simple as you see there. So I just rearrange this and put the OB first minus OA. And that's your triangle law. So AB, this displacement vector, is always equal to the second position vector minus the first one. If you want a deeper understanding of that, you want to see it with like primary school breakdown. Break it down to me like if I'm 3 years old, just search it up on my channel. So it is parallel. They are parallel. We can see that BC is actually 3 times BA. So that's one geometrical relationship. It's enlarged by 3. It's 3 times the size of BA. But also, they are parallel. Got it? Do we know if they are collinear or not? Yes, they are collinear because they share the common point. So they are also collinear. Once they parallel and share a common point, they are also collinear, which we explained earlier for those of you who just jumped in. Draw a sketch to show the relative position. So they want sketches. Well, sketches are easy in this case because A is really 6, 2. Visualize where that will be, 6, 2. This one is 3, 4. Visualize 3, 4. So you come back a little bit, go up a little higher. And this one is 12, negative 2. So you go quick all the way down to 12. So really we want up to 12 here. Understand? 6. And we're also looking at 3. So 3, 4 should be something like this. That's B. 6, 2 will be something like this. That's, who is that? That is A. And 12, negative 2 will be, oh gosh, right here. So that is C. So B actually closer this way. So this B is 3, 4. A is 6, 2, and C is 12, negative 2. And we can probably put a nice little dotted line here to show that they are collinear. How are you feeling about vectors? Will you get a little clarity there? You understand where you need to recap? This is a more exact description. Now notice how they show the OA, OB, OA, OC. Let's do another one of this style. Find the value of MK, SL, and OS. I'm giving you like 1 minute. So those of you who are watching in the future, just skip ahead. I'm just giving them a little 1 minute to soak it in. Try and get MK. Look, you had to read the question. There's this relationship. And then they give you the values. OK is V, OM is U, but they also draw it here. And now they're asking you MK, which is 3 marks. You probably don't know what MK is already. I realize they make a mistake there. Equal instead of plus. That looks like a typo. Right, so MK means we're going from M to O instead, because we don't know MK, of course. And then you're going from, now when you see O, that is a position vector, but you don't really get the position vector stuff here. This is the geometry side of things. MO is negative U plus V. Let's stop right there. SL is what? So SL looking a little scary because SL, which means we need to find SK, which means we need to understand what SK is. Well, SK is what we need to multiply by 2 to figure out what MS is. Be careful, that is not half mark. SK times 2 is MS, so that means it's almost like if you have 3 parts here. MS is twice the length of SK. That's what I'm showing you all about these things. Be careful with these things. You have to watch what points they're talking about. Sometimes they might put MK here. It's 2 times SK, which means different. That means it's in the middle. Think about it. So MS is 2 times SK. I know I've seen primary school students in the mix, but I'm Zalika. So MS is equal to 2 SK. So how do we find what SL is? Well, if MS is 2 times SK, it means SK is actually half, 1/3 of the way that we just got for MK. Tell me if you understand why. SK is 1/3 of the whole thing MK is. So SK is 1/3 of MK. Now the reason I'm finding SK is because I want to find SK and then find KL, and that's how I'll find SL. And I already know KL is U. So I'll write this. 1/3 MK is just, by the way, 1/3. Remember, I can switch this around to V minus U so it looks a little neater. Like put the U on that side. V minus U. So 1/3 of V minus U. MK is minus U plus V. MK, what we just figured out, is minus U plus V. I switched it around. I put V minus U. So I just, then I can bring it across the equal sign. So the signs don't change. It stays with the number. So 1/3 V minus U is SK. So SL is really SK plus KL. It's just the fractions. It's just the fractions alone. That's why I need to practice it. The fractions is what throw people off in this all the time. V minus U. I substitute in. SK is really this. Plus KL, which is just U. So this is like 1/3 of V minus 1/3 of U plus U. 1 minus 1/3 is 2/3. So this is 1/3 of V plus 2/3 of U. And that's the answer. OS now, it's not looking like it's collinear, but it might be. It very well might be in the question. We'll see. OS, no, it's not. It's not. They didn't say. So I'm going to stop trying to make it look collinear. Trying to scratch it off. OS. So to find OS, I would go down the V. Tell me if you live with me. OS, I would go O to K and then go backwards. K to S. K to S is the reverse of this, right? K to S is negative 1/3 V minus U. Now, they didn't ask about parallel or anything, so you don't need to worry about that. O to K would be V. KS is negative 1/3 V minus U. The reason I scratch off the plus, positive and negative is negative. So let me take the time with this. V minus 1/3 V, negative and negative will make a positive, plus 1/3 U. V minus 1/3 V is actually 2/3 V plus 1/3 U, and that's your answer there. So it's all about the fractions. It's all about the fractions. This style of vectors, this heavy level of vectors, is just being able to deal with all these fractions that are flying at you. You want to practice them over and over and over and over and over until you feel confident with them. So there are some more questions here, but I think we exhausted all the different ideas that come with vectors. So those of you all in the work in the student hub, there are these 2 questions that you all can try for yourself. The solutions are right there. Those of you all that are not in the student hub, maybe you're trying to do everything free. You don't want to pay for no crash course. You want to do it free. search www.kerwinspringer.com. Don't search it now, search it after I finish the live. And you would be able to see solutions to past papers here. So on the solutions to past papers, you can try to look up all the vectors questions and do them like that. Those of y'all in the crash course group, y'all will get these things sent to you by tomorrow for the latest. So what's next? Well, ladies and gentlemen, it's time for matrices. Now, what is about to happen here is what I would say is the toughest thing for CXC. Like literally the toughest thing. It doesn't get harder than this for CSEC maths, right? Are you hear what I'm saying? I'm about to teach the hardest subject. A workshop on the hardest subject in CSEC maths. So I'm going to sit down for this one. I'm real tired of drinking coffee to stay awake, all kind of thing. So let me take a seat. While I'm taking a seat, I'll go and see if I can touch grass somewhere. I want to try and touch some grass. What's the vibe? What countries we still have any dance? I know we are real Trinidad, we have some Guyana, we have some Grenada. Oh yes. Why people running away since I say this is the hardest topic? We had over 300, now we dropped to 299. And I press like on the stream, share it up. And I take a picture yet? You'll take a picture and share it in the groups. Well, I mean, or on your status. Let the people them know to fall in line. So Leila is asking if there's going to be a recording. Yes, it's going to stay right here on this channel. So you can just use the very same link and click on it. St. Vincent in the dance. Big up Deja. Janelle even change. This is my church close to. I just come from church. All right, enough talk, enough break. Now we begin the toughest topic in CSEC maths, which is matrix transformation. So it's either matrix transformation or linear programming. Well, linear programming doesn't come as hard these days. It could still potentially come as hard, but matrix transformation has been doing wondrous things in the recent past. So before we do matrix transformations, you must understand transformations. So this workshop actually is on transformations. Just now, let me see. This is just straight transformations. Right, yeah, there we go into some matrix transformation style stuff at the ending. I'll still need to do some extra stuff because that didn't go as deep as it could go. This is still surface level. This is actually a really nice workshop here. So in the crash course, which will happen next week, we have it Monday, Tuesday, then the following Monday and Tuesday. Those of you who are interested to register for that crash course, +1 868 310 1306. You just WhatsApp that number on the inside. There are other numbers for other countries, but it works right across the Caribbean. This number will work anyway, and it's a WhatsApp number, so you just WhatsApp that number and you'll be able to sign up. We have students from every island in the Caribbean in that crash course. It's the Student Hub. You know the Student Hub? Do you know the Student Hub? Ask anybody from the year before about the Student Hub. There's also something called the Student Hub Discord channel, which is free. So if you go at the Student Hub on Instagram, you'll see the link in the bio and you can click there and you can go on the Discord channel and you can get any past people you're looking for. Why isn't it chat if you ever visited the Student Hub Discord channel before? Now you have to know how to use Discord because it have 30,000 students in that channel. Over the years now they build up. But so it could get hectic. If you know how to use Discord, like you use Discord for gaming and stuff, you go on that channel and if you know how to search, you can find stuff that you're looking for. You can also find important other stuff too that I can't mention here. So the topic of transformation can come in two sections. So it can come in section 1, usually shows up in question 3. This is normal graphical transformation. Simple stuff, translation, reflection, enlargement, rotation. These are the 4 types of transformation. Translation, reflection, enlargement. Hey, Leila, are you? And rotation. Now the duck can show up in question 10. So this is the gangster question here. when it comes in matrices, then it's tested in vectors and matrices point of view. So this is where you use a matrix to do the transformation. For example, this is going to be represent a reflection in the x-axis. So if you had something there, it will reflect like this. So you can use a matrix to do the transformation. All right. Yes, time speed it. We will send the PDFs to you guys. So let's talk about them in order. So this is actually an easy lineup before we go into the tougher stuff. My camera started moving again. It's showing my bush, showing all the grass and having the corner there and thing. Let's see if I can get my camera to behave itself. 4 types of transformations that you need to know: translation, reflection, and enlargement. Camera. My camera refused to stay put. Sorry about the distraction earlier. I really need to. My camera will be real moving now. Sorry about that. So you have translation, reflection, enlargement, rotation. Translation is easy. Consider the graph below. Look at A. Look at A. Look at A. A went from here to there. Oh, no. Which one do you think it went to first? It actually went from here to down here first. And it used a translation, and then it went up there. Now, it didn't seem like it have any flip or anything going on here. This just seemed to just appear over there. That's a translation. Translation tells you how much it goes across and then how much it goes down. So you use a vector for translation, just like what we were just doing. Yes, time speed. The camera is following my face. So it goes 1, 2, 3, and then it went down 1, 2, 3, 4, 5. So how do you think we'll describe this translation? So if there's a translation called T, T represents you go across 3 and you go down how much I count? 5, 1, 5. That's it. Why is in the chat if you understand? 3, -5. And then if we call this translation Q, we can represent Q via what numbers you think we'll put here. So translations are easy. They are really just like a vector. What numbers you think we'll put up top and below? To go from A prime, we call this A prime, that little line A prime, to A double prime. Well, I'll have to go across 1. Then I'll have to go up 1, 2, 3. So this is 1, 3. Well, then Kyle killing it right now. Let's go see what they talk about. Translation from A to A prime, you go across 3, you go down 5. So the translation from A to A prime is 3, -5. Translation from A prime to A double prime, you went across 1, go up 3. So it's 1, 3. You can translate shapes as well. For example, here I have the shape PQR that slid all the way to PQR prime. What do you think is the translation that caused this to happen? If we call the translation, you can call it a transformation too, but it's specifically a translation. What do you think we'll call it? What is this vector that did this translation? So you're seeing to describe a translation in entirety, all you need is the vector. Zion asking if there's another way to work it out. No. What other way? I don't understand what you mean by that question. You do understand what you're asking me? That's like if I say you start at 1 and you go to 3. So you just say 3 minus 1 is 2. Is there another way to work out this? Well, you count it 1, 2. I don't understand what you mean another way. What you need another way for? So we went from Q to Q prime. So I see all kind of 4s and 2s and things showing up in the chat there. What it really is. What it really is. So like if you want like a mathematical inside way to do it, you can like use the points maybe. You can say Q, you check 1 point, Q is 1, well, -1, 3. Why is in chat if you agree? Q is -1, 3. Actually, don't press Y, don't press Y, don't press Y. Q prime is 3, 1, and we just subtract to see the translation. Q prime minus Q is like 3, 1, and we see what happened here. I get tired. Negative 1, 3. And right, so you get 3 minus, so you get 4, 1 minus 3 is negative 2. 4, negative 2 earlier. So the translation is 4, negative 2. So like you could like work it out like this. You could count it 1, 2, 3, 4. Went down 1, 2, 4, negative 2. Translations are so easy, they don't really bring translations. They bring it in, I don't know, just like 1 mark and they go on to the other stuff. You understand? What is another name for translations? So translation is the official big boy name on the birth certificate. But there's 2 other simpler names that students like to call it. One starts with S, one starts with G, and they rhyme with each other. So yes, a slide and a glide. So a slide and a glide. So that's it. To describe a translation fully, you need to know the vector. Sometimes they can give you the vector. Sometimes they can ask you for the vector. They give you the 2 points, ask for the vector. They give you 1 point, give you the translation, tell you where the other point is going. For example, if I said, let me see if I have it below before I continue. Now, going into the next one. So, like if I told you, I want you to use the same translation on this point here. I have this point M. Find M prime using the same translation. Where M? 4, negative 2. Well, then you need to go 1, 2, 3, 4, negative 2. M prime going to be over here. Or you could say M prime would be equal to M plus the translation. So M is negative 3, 1 plus the translation is 4, negative 2. So you get 1, 4, negative 3 plus 4 is 1, 1. This was negative 1 plus negative 2 is negative 3, 1, negative 3. So M prime is 1, negative 3. Rate out of 10, how much y'all understand translations, ladies and gents? That's our translation right there. So let's move into the next one. Now we're going in order of difficulty. So when usually last one, that'll actually be the most difficult, but they're not very difficult from this perspective. It's only when they get into matrices, you have some challenges. A reflection, the other word for reflection out here is flip. People love to use that word, but we big now, so we'll call it a reflection. A reflection is identified when you're getting a mirror image effect. You obtain a symmetrical effect. So it's the mirror of this is called the object. This is called the image. The reflected or the thing that was transformed is called the, well, they're looking like these twins. One is the object, the original is the object, the imitation is the image. The result is the image. Now, even with this, this is the object, and you translate it, and you got the image. It doesn't only work for reflection. They sometimes use the word object and image for any type of transformation. Understand that there are 4 types of transformation you need to know: translation, reflection, enlargement, rotation. So a reflection can just be described. All you need to do to describe a reflection is to know the equation of the mirror line. Of course, in matrices, there's a little more, like you need to know the actual thing that does the reflection. Like I told you, this matrix does a reflection in the x-axis. This one will do a reflection in the y-axis. More on that later, maybe in the crash course, we'll touch that. So all I need to know is where to put the mirror line. Where to put the mirror line. So let's go see some stuff. 2 things you should know: how to create a reflection and how to interpret a reflection. So, all right, they wanted to start creating a reflection. Do you know these days they are skipping all the construction question? These days, it's been a while. Have you seen that in the few past papers, like the last 4, 5, 6 past papers? Used to be, they give you something to construct like this. They still could, You construct your 30 degrees and you go up here and then you construct a 90 degrees. Maybe you wanted one here. So you construct the 90 degrees. Why isn't it chat if you know how to do these things? You run up your 90 degrees and bang, and then you draw a point and you write a PQR, triangle PQR. And after you get a triangle nice and good day, well, All you understand what I'm saying? You might have to measure one side and bang, bang, bang. That used to be the thing. TD students used to love this because it's like 3 marks. It's a really easy version to TD. So how to create a reflection? If you have the mirror line, you already know where the mirror line is. You have the point. You have the shape. Let me show you. Let me show you. Let me tell you something. Let me tell you something. Let me show you. Let me show you some love and reflection. So if you have a point like, maybe you have a point like this, and you want to draw the reflection of this triangle, all you need is 90 degrees to the mirror line. You need 90 degrees to the mirror line. So each one of these need to go 90 degrees to the mirror line. You know what I mean by 90 degrees? Normal right angle. So that's one. So you can usually accomplish this with your set square. So 90 degrees to the mirror line. And then what else you need? Remember, you want to show the construction, right? You don't want to just draw it. You need to take your compass. Your compass is the thing that look like this. Some of you might have the one with the where you put a pencil on the side here. You know what I'm talking about? There's your compass. This part stick into the right paper and you draw a circle. So you open your compass, stick it in here, draw a little dash there. So that's how you get the length. And then you just circle back around and you draw a dash here. Open it, stick your compass here, open it here. You're visualizing this. You see an invisible compass. You see the compass do anything? You stick it there, the pencil, draw there, right? Then you just spin it around, still stuck there, and you make your next, you continue the circle there. Stick it there, draw. It comes back around and makes a swipe right there. Yeah, so SEA, we just count it. But you see, sometimes you get some weird mirror lines and stuff now. You want to show your working. So like sometimes, let's say this is your, let's say they drop, excuse me, let's say they drop something like this and they draw the mirror line like this. Like this. What are you going to do? See why the method works for everything? You can't really count these squares because the mirror line diagonal, it's not even 45 degrees. So you can't say it's over here. That would be wrong. So your only way you can do this now is with the method. You have to use the right angle here. Right angles to the thing. Right angles. Draw your cut. So it wouldn't cut in nice spots. And then you connect the dots like this. Right, so that's the proper way if you want to create the image and you know the mirror line. What usually comes, what has been coming these years is that instead of that, they're giving you the two of them and they're asking you to find the mirror line. You know what I mean by the two of them? Like they give you the two objects, the object and the image, I want to say, and they ask you to find the mirror line. So let's say I have an object here. Bang, bang. Bang, bang. And I mean, I just drawing things here. I'm really paying too much thought into this right now. Maybe this guy even reflect, who knows? Yeah, this seeming like you're supposed to go up there a little higher. What is this? 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. All right. If this is one. I just tried to come up with a nice little thing for you here. Don't worry yourself. That's where the saying it should go. And where this one should go, maybe like here, so. right? So yeah, so let's say we have this. We try to find where some of you all already know what the reflection line for this is. What is the equation of the line of reflection for this one? Maybe some of you all could see it already. What is the equation of the line of reflection? Now, if they want you to draw it on the paper, which they have been asking recently, if you go back and watch like 2023, 24, somewhere around there, they asked that. Yeah, very good, Marvel 2603. Here's our boss. The equation of the line of reflection is this. This line is called y is equal to x. You can see it now. But if they ask you to construct this to find the line of reflection, or let's say it wasn't even this y equal x, they just wanted you to construct it. It's very simple how to do it. To do that, all you need to do is connect the respective points. Like if this is PQR, then this would be P prime, Q prime, R prime. You can't just name it willy-nilly, yeah? Blessings, Aaron. You can't just name it willy-nilly. It had a mark up properly. You see that? And then, no, you can't. Remember, we don't know what our line is. You want to construct it. So what you're supposed to do is join the two together. Join the R and the R1. And do you know how to bisect a line? Do you know how to bisect a line, chat? If you have a line and they ask you to bisect it, take your compass, stick it in here, go a little past half, draw the arc. You all know about that? You could search Kerwin Springer construction to see the whole rundown on construction. Draw next one there. It's not supposed to come on like that. I just fighting up here, fighting a good fight. I don't have the compass thing for this. And when you cut through, boom, you bisect the line. So just research that, how to bisect the line, and that's effectively what you're going to have to do here. So you'll end up drawing an arc, maybe something like this, and another arc, maybe something like this. And if you do the perpendicular bisector, you'll actually just get it one time. But what they like to see is that you do two. So maybe you do this one as well. You connect the two. Why didn't draw in a straight line? Why isn't each other following? You connect the 2 points, P and P prime, bisect it again. So maybe we ended up with something like this and this. And then once you join those perpendicular bisectors, you would have created the line of refraction. That's it. That's how to get reflection. So let's go see what we have in the notes. We are on the second one. We have 2 more to go. Once we have the object, we need to only know the mirror line. So once you have the object, to get the image, you only need to know the mirror line. The mirror line is, if it's a vertical mirror line, it will be in the form x is equal to something. So this equation of this line is called x is equal to 2. Class, we cooking. X is equal to 2 is the mirror line here. If I had x is equal to 3, that would be this line. But this will get pushed back all the way to here. See that? That's the equation of the line. If the line is vertical, well, you'll call it y equal to 3. Why do you call these vertical lines and horizontal lines y is equal to 3 or x is equal to 3 or x is equal to whatever number? Because it's literally the line where x is forever going to be 3 on this, y is forever going to be 3 on this line. X is forever going to be 2 every point on that line. So if you have the image and the reflection, you can just count in this case. Yes, 1, 2, 3, 1, 2, 3. Of course, don't go and construct unless they want you to construct it. Just count if you have to count, and you're good to go. In this case, the line x is equal to 0 is also called what? The line x is equal to 0 is code name for the y-axis. Know that. The line x is equal to somebody say you're all cooking and I still trying to find the ingredients. Heartbreak. But the line x is equal to 0 is the y-axis. But we have people cooking, man. Look at Wise. Darcel, King, Shane, Kenya, Bones, Daniel, Tariq. We have some big time chefs here. Keep it up. And those of you who fight it for ingredients, look hard. Now, notice what happens if this is the mirror line. Like, if there's a point on the mirror line, it doesn't move. Like, if I try to reflect this triangle, what's the triangle I have here, right? If I try to reflect this triangle, what do you think would happen? Try and visualize it. This point will stay there. See that? These will get to reflect two away. So more like here. 1, 2 away. So here. But any point that is on the mirror line, the reflection stays on the mirror line. We cooking again. Any point on the mirror line remains the same. B is the same as B prime. What's the horizontal mirror line here? This was the image. This is the x-axis. But the reflection was y is equal to -1. And it reflected across this way. Well, again, a little settled feeling in the stomach. The line y is equal to 0 is also known as the x-axis. So the line x is equal to 0 is known as the y-axis, because all along the y-axis, x is 0. All along the x-axis, y is 0. We keep it pumping. We saw some reflections in the line y is equal to x. That's very popular as well. Notice the kind of vibe you get when you reflect stuff in this line. Let's make a random triangle like this. Like this one here. So if I reflect this point is on the line, so we can fully expect the reflection to be on the line. So how do you figure out this point? Now, something that happens with the line y is equal to x. When you reflect it, the numbers swap around. So like if this is 2, 5, the reflection for this point, let's say this triangle is ABC. ABC. The reflection for C will be what? If this is 2, 5 and the reflecting line y is equal to x, is going to be 5, 2. So that's a useful piece of tip to remember. This will remain the same. It's 4, 4, so you can't switch around 4, 4. It remains there. This one is 3, 0, or actually 0, 3. So the reflection will be 3, 0, which is over there. And just like that, we have the reflected triangle. All of these things coming together. Reflections. All the tips that I talked about right there, or you could swap the x and y to find the image. If you have a mirror line, y is equal to x, and you try to reflect this, it reflects right there. We cooking. This is the line y is equal to -x. Remember, we just did the line y is equal to x that looks like this. The line y is equal to x looks like this. The line y is equal to -x is just the flip of that. All along this line, y is equal to the -x value. So if x is 2, y is -2, y is equal to -x. But the same vibe happens, actually the other way, when you reflect something. Keep it going. So consider the graph below. How do we find the reflected line? Connect the two, bisect, perpendicular bisector. Let's see what they suggest. See? You see how we connect the two? You see it? Why is it in the chat if you see in this class? You see how we get the perpendicular bisector? Remember I did this just now? Now we know that this is the line x is equal to 1 because it's cutting through 1. Good job, Kyle. So we're moving on into enlargement. So I'm going to consensus everything at the end, right? Hang on. We just have like 15 more minutes again. I'm going to consensus. Let's know. Somebody from class then or something. That looking like Lolita. That looking like that maths. Lolita, where's that one? Where's that one? So the axis of reflection, just kidding, buddy. Here. The axis of reflection is x is equal to 1, the transformation. All right, we did that already. So we're moving into enlargement. Now, remember, We did so far what we do translation. For translation, all you needed to know is a vector, x, y, and these were numbers. We did reflection. For reflection, all you needed to know was the equation of the line of reflection. Like maybe it was x equal to 3 or y is equal to x. So you can even get a whole normal line like y is equal to 2x plus 1. You can reflect in lines like that. For this one, you need to know the scale factor and the center of enlargement. You see how we're getting more things to know? Rotation is the worst. You have 3 things to know. So there's usually 3 situations that happen with enlargement. The scale factor is greater than 1. The scale fraction is a decimal. They almost never give negative decimals. I've never seen a negative decimal, but they could. The scale fraction is a decimal, which means this is a reduction. Or the scale factor is negative, less than 0. If the scale factor is negative, what does that mean? What happens here? So these are the 3 situations we want to look at. All of them have come for CXC already. All. So it can be a flip of a coin. But you need to know the scale factor and you need to know the center of enlargement. Center of enlargement, easy. Let's check. So this is where the scale factor is greater than 1. Can you see the object? This is the object, ABC. Can you see the image? A prime, B prime, C prime. What do you think the scale factor of enlargement is, class? What do you think the scale factor of enlargement is? Scale factor of enlargement is what? It's time for me to stand again. Yes, it's 2. Because one side AB looks like about 2, and then A prime B prime looks like 4. You can clearly see this triangle is twice as large in terms of linear, in terms of the sides, not the area. The area will be 4 times as big. So pretty cool, right? Understood? So the scale factor, you all can just use your eyes and see that it's 2. The proper way to find the scale factor, it will be A prime B prime, the length A prime B prime over AB. So A prime B prime is 1, 2, 3, 4, and AB is 2. So the scale factor is 2. You use a side on the image divided by a side length of image divided by length of object. So far, so good. So, what else I can talk about this? Oh yeah, one more thing. What is the center of enlargement? What is the center of enlargement, class? The center of enlargement in this case is the origin, which coordinates are 0, 0. Very good. So you can't just put 0, you have to put 0, 0. And to get the center of, very good, you connect all the vertices and it will just direct you to the center of enlargement. Let's keep pumping. This happens when the center of enlargement is not the origin. It's basically the same thing. What the scale factor here looks like it's 3. Can you see that it's 3? Let's see. This is 2 and this is 1, 2, 3, 4, 5, 6. Yes, so this. Why isn't it if you see that the scale factor actually is 3? But the center of enlargement is not the origin, it's over here. So how would you find the center of enlargement? You just connect the B with the B prime, draw that straight line. So you have no main set of construction to do with your compass. You're just connecting lines and you'll pull down into the center of enlargement. So this is what happens when the scale factor is a fraction. Like the scale factor could be a half. That means it's a reduction. That means the object is here. Can you see that this is the element? The image is actually over here. the image is smaller than the object. It feels like if it's an enlargement, but it's a reduction because you actually started with this one. So if the scale factor is a half, you see, understand what happened in here. It reduces. So if you connect 0 to n, you want to get half of that to find where the n prime would land. Or Lm, remember the length of the image over Lm is a half. Lm is half. Well, let's not use Lm. Let's use something I can easily see. No fractions. Ln prime and Ln normal. Ln is how much? Half plus a half plus a half, or 2. Ln is 1, 2, 3, 4. 2 over 4 is a half. Rate out of 10, how much you'll understand in enlargements. These things becoming clear to you, the chances of this coming is like nearly 100%. One of them is going to come. One of them is going to come for the exam. So when the scale factor is negative, the way this thing happens. So like if you have a scale factor of -2, instead of getting an enlargement that looks like this, where it goes up by 2, the thing is go backwards inside the number line like this, and it also flips. So you end up with something that looks like this. It doesn't reduce. If it's negative, it doesn't reduce. When does it reduce? It reduces when it's a fraction. Now you can get negative fractions, which will let it reduce inside this. It will flip and reduce. But it must be a fraction to reduce. If it's just negative, it flips across the origin. What do you think the scale factor of enlargement is in this case? Look at this. What do you think the scale factor of enlargement is here? Hint. Did it even enlarge? And then enlarge. Scale factor is what? It's the same thing. So the scale factor have to be very good. And remember to put the negative journal, not 0. If the scale factor is 0, if the scale factor is 0, we real problems. It's -1. It's 1. So when the scale factor is 1, it remains the same size. We keep it pumping. What do you think the scale factor of enlargement is here, class? This length is twice this length. So what is the scale factor? The scale factor of enlargement for this is -2. Excellent. Ooh, and everybody remember, even Zach, no trap cards for Zach. Well done, Mr. Zach. So -2 from the center, 0, 0. All right, so we're moving into rotation. As we do in the crash course, Monday, Tuesday, then next Monday, Tuesday, not this Monday, the following one. We'll come across these questions in some of the past papers and you'll see how to handle them. There are 3 things you must know for rotation. Rotation, final thing for the day earlier. For rotation, you need to know how many degrees. That's 1. How many degrees? You need to know the center of rotation. That's 2. And then you need to know the direction of rotation. Sometimes you don't need to know. Only if you're rotating 180 degrees, it don't matter if you go anti-clockwise or clockwise, you'll end up in the same spot. Think about it. If I turn around this way, I still end up in the same spot, right? 180. Wait, what the camera do when I do that? The camera wasn't panning and showing my whole room and thing. Yeah. So these are the 3 things you need to know for rotation. What do you think? Just a quick recap. Translation. All we needed to know, translation. All we needed to know was the vector, like go across 2, go up 5. Reflection, all we needed to know was the equation of the line of reflection, like y equal x, reflecting the line. For the, what we just do, enlargement, what you needed to know was 2 things. You needed to know the center, most of the time it's the origin, and you needed to know the scale factor. So now reach the last one, which is rotation, which is 3 things you need to know. That. How many degrees, center of rotation, direction of rotation. So So rotations can be done using matrices. Now in the basic geometry that comes in question 3, they don't usually bring matrices. So they'll just tell you the rotation and you need to figure it out. But these are some that you can memorize for the matrices, so later on when you hit this. When you go deeper into matrix transformation. I thought I was going deeper today, but apparently I just touching this surface here. Sorry, we'll catch you rest of it in the crash course. 0, 1, -1, 0, -1, 0, 0, -1. Who knows? I might try the TikTok live later if I catch energy. Because I see I could go live on TikTok. Let me make sure the permissions and whatever. And I've seen TikTok real pumping these days. By the way, if you have TikTok, don't download it back. I'm not going to do anything extra on TikTok that I'm not doing on YouTube. I don't have on YouTube. So TikTok distracting now. Anyhow, rotation 90 degrees clock or 270 degrees clockwise. That's like this. Focus, lock in. Let's say I have this triangle and I want to rotate 90 degrees clockwise. Rotate. Visualize where you think it will end up. Visualize it first. Rotate it 90 degrees clockwise in your mind. Where do you think it will go? Where do you think it will go? Well, it goes here, like this. Was that what you were thinking? Or were you thinking this? Because that is a reflection. Actually, I don't know what that is. If you're thinking this, that is a reflection. If I want to rotate it 180 degrees, visualize that one. Where do you think this will go if I want to rotate it 180 degrees? All the way around, and you'll end up like this. Now, that's if I'm using the origin, right? So you use your compass and you go 180 degrees for each one of them. This is wrong. Is this? No, this is correct. Am I doing the right thing? Yes, connect, yes, correct. So your rotation will end up like this. How about 270 degrees or just 90 degrees clockwise? Visualize that. Where would it go? So if I do 90 degrees, can you check it out? Like this will go 90. I'm drawing that too good. Drawing ain't coming out 200. And you see that I will do some kind of something like this. Is that what you're thinking? So just fall along like that. Okay, so that's common rotations. Reflection and matrices. Now we'll catch a little more about this because, okay, let me just actually say it since this was a whole workshop. Let me just do it real fast. Like if you need to show a reflection, everybody just looking, we're about to finish. If you need to show how to do the reflection, shout out to the people who are here from start to finish. Were you here from start to finish? Like if I have, let's use back the same triangle idea. I have this triangle. And I want to find the rotation. I am given that it rotating about the origin and 90 degrees and clockwise, the three things. Now I want to construct it. So they want me to show or construct using a compass. Well, you use the origin, you use your compass and you're drawing circles from each point. And then from these circles, you need to draw. So that wouldn't be correct. It would be like this more. You need to draw right angles. Just now I have visualizing all happening here to get my circles to line up properly. Maybe like this. My circles them encircling properly, yeah, but you catch the idea. So if you have a compass, you get nice perfect circles. You know the compass, you're using your compass, the pencil is on this side. Points, the stabby point is on that side there. You stick this right there, open them out, draw the circle, draw the last circle here too. So what will happen after you draw the circle, what you want to do is actually construct a 90 degrees or use your set square to show that you did 90 degrees this way. And then you do 90 degrees this way because you have to get the angle. And then where it cuts the line is where you want to draw your reflection. This will go up somewhere up there. So, you know. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And stop right there. And that's your reflection. So that's how you would do the reflection if you have to construct it. If what came recently is that they didn't give you to construct it, they give you the two of them, and they ask you to find the center of reflection. So what do you do in that scenario? If you have to find the center of reflection. All right, well, this is how you find the center of reflection. Last thing, everybody, lock in. To find the center of reflection, you connect the respective points. So let's say this is A, B, C. We have A, B, C. You connect the A's. Well, obviously, this one will be the A prime, B prime, C prime. You connect the points. Let's stop moaning and groaning in the chat there. You connect the points. Let's say I connect A with A. You just need to connect 2 and C with C prime. And you're doing the same perpendicular bisector stuff. Remember how we do that? So we're doing the same perpendicular bisector. And where this line meets this perpendicular bisector is going to be the center point. So that actually came recently. So that is the type of construction that happens for CXC these days. That's what they're really bringing, construction involving geometry. There's a strong chance something that I show you today in transformation will come. And I waste some time in showing all your relevant things. So one of these styles of transformation will come, and maybe you might have to construct to find the center of enlargement or center of reflection or rotation or something. And when it comes and I do these solutions, I will say, I told you so. So that's how you would find it. So I'm more on this in the crash course when we're doing some questions. Just some quick touches before we go, like 1 minute. Suppose that ABC underwent a reflection. The thing that we use to make this reflection is this. Those of y'all who revise matrices, why is in the chat if you revise matrices yet? Matrices is 3 marks, the first part, so you should revise it. I have a whole series of matrices that's very effective, right on my Kerwin Springer channel, not this one. So revise that. And you would, if you revise matrices, you'd have known that this matrix has a name. It's called the identity matrix. And any number you multiply by the identity matrix remains the same. Identity means remains the same. If you use the identity, it means they're like identical. Identity in an operation doesn't change the object from the image. For example, the additive identity is 0. Any number I add 0 to, I'll get 4. 5 plus 0. Not 4, you get back the same number. 10 plus 10 minus 0 is still 10. You understand what I'm saying? 0 is the additive identity. The multiplicative identity is 1. Multiply by 1, it remains the same. The matrix identity is this weird thing, 1, 0, 0, 1. That's 2 by 2 matrix identity. So if I have any vector or anything like that, or any other matrix, let's say 3, 4, 6, 10. If I multiply by the identity matrix, I get back the same matrix. I will get back 3, 4, it looks like a negative 6, 10. That's the power of the identity matrix. So now, if you begin to do little spicy thing, you begin to spice up the identity matrix, like put a negative sign there, all of a sudden, the number kind of remains the same, but maybe the x might change. So if I multiply the identity matrix by this point, what is this point? 1, 4. And I have a negative on that, then what will happen is negative 1 by 1 turns into negative 1. 0 by 4 is 0. 0 by 1 is 0. Yeah, then how to do matrix multiplication. 1 by 4 is 4. So you end up with negative 1, 4. The x coordinate turned negative. That's how we use matrices to show reflections, rotations, or enlargements. We can spice up the identity matrix. So this is an example. See, he's staying there. Here are some general ideas. This is reflection in the y-axis. This is reflection in the x-axis. This is a reflection. Notice how it vice versa. The normal one was 1, 0, 0, 1. That's the identity matrix, capital I. If I swap it around, it causes a reflection in the y equal x line. Reflection in the line y is equal to x. If I put a negative sign, this is reflection in the line y is equal to negative x. What do you think will happen if I have this? 2, 0, 0, 2. What type of transformation do you expect? So my official crash course starts on Monday, Tuesday, not this week, following week, and then it goes the next Monday and Tuesday again. Students in the student hub in my maths class and my studio maths class will get access to this. It's 3 hours every day. I will be coming online live again before then. But if you all want to join this crash course, the cost of it is 300 TTD, about 40 something US dollars, and you can WhatsApp this number +1 868 3. I nearly put my personal number there, but I hope I never do that. 31006. Next thing, wow, 200 people messaging on my phone, and you WhatsApp this, right? Okay, so yes, this is not a reflection in line y equal to negative x. This is an enlargement. Good job, Zach. This will enlarge, and the scale factor will be 2. And that's all she wrote, folks. So ends our workshop on transformation. I have to change it because I had transformation matrices and vectors. So we did vectors extensively. We did transformation up to the point where you need to know. And we tutted into matrices a little bit. So we'll pick up back some more on this next week Sunday. Once I get some energy, I won't be doing this. I would probably be doing an algebra workshop that I already have prepped. And algebra is foundational work. So everybody should be, this is like advanced stuff, what we just did, the ending of revision thing. So don't worry about if I'm posting this to the drive. This live stays right here. Just use the same link. I'm not deleting it. It stays right here. You can just watch it over anytime. Additionally, the notes for this live, you all can remind Mr. Josiah. He's probably seeing this as well. So we'll send it to all the maths classes. You know, I have class Monday, Tuesday, Thursday, crash course group as well. You all will get it. So I think that's it. I think that's all of our lessons there. I hope this helped to jumpstart some revision and you see what ideas you need to learn for. All of these questions that we did come in question 10 and 9. So the transformation can show up in 10 in matrices. Question 9, we didn't do anything from question 9. Question 10, this is basically a question 10 revision because we reviewed vectors as well, which shows up in half of question 10. Also, question 3 is where the basic transformation will show up. So you're not doing the series you did last year? No, I'm not doing the full series. I already have it. It's on my YouTube channel. You can watch it over. It's still applicable. Everything is still good there. So no need to do over the exact same series. Love and blessings. Practice time. Peace in ways. So what are we doing tomorrow? Tomorrow we have maths. Multiple choice, I believe we are on. We are doing multiple choice. For those of you who have my class with me tomorrow, may come back on 8 o'clock tomorrow. I might fiddle around. I just like to come on live and do some maths, and there's a vibe for me. POB, I don't know POB, but I'll get one of our teachers to come on live and do some stuff. Love and blessings from Ducky Leila. Hold it down. Bye, sir. Enjoy your evening. Bye, sir. Thank you for the little recap. So, would you ever do matrices workshop again? I have good matrices stuff online. What I'm doing this year is trends. Since I have so much stuff already online, you just need to literally search it. You know? Marvel, just type Kerwin Springer matrices and you'll see real thing. Good stuff. You can see the short videos where I do it real concise, or you can see these type of videos where I talk real plenty. And you might have to skip and pay it on 1.5 speed and thing. But it's still good stuff, real good stuff. This was very helpful. I appreciate it from Grenada. Blessings. Next week, Sunday, most likely, when you're doing quadratic graphs, I have that online already. Search quadratic graphs, Kerwin Springer. We'll try to get some bio in the mix. Love and blessings, Zach, Malika, Brian. Yeah, eating time. My wife can't put on some food for me here now. I'm gonna deal with that just now. Sadie, you welcome. Marvel, yeah man, blessings, blessings. 18 night, yeah, late night with Springs. Love from Barbados. All the way. Love Barbados. The only thing we do really love from Barbados is CXE headquarters. But everything else in Barbados we love. We love the people, the beach, the vibes, even Prime Minister or President. I'll see she have fans across the Caribbean. 18 night, Justin. Ting. Well, in God we trust, but I will help all you too. Dene, Kendall, Kenya, POA in the mix. So we have good POA teachers too. I don't know how interested they are to coming on live. My brethren is adaptation, and he has a channel with some good stuff on it as well. Or Mrs. Bringer make. You're trying to get me to walk around my rooms, because you know my camera stick on following me, and you nearly catch me. Agri science, nah, ain't getting that. We do have an agri science teacher in the student term. Some chem, yeah, we can handle some chem. We have a boss chem teacher in the student term. Adaptation. If you pop in there, you can let him know Mr. Springer sent him. His name is Chris. Adaptation. So you have few channels I recommend, few places I recommend, because it have not good stuff out there. I don't know, sound like I'm bashing anybody, but things that could just confuse you and not the right teaching methods. So I recommend adaptation. I recommend make IT simple TT. There's some good channels that I know. I'm not leaving out somebody. Oh, Mr. Terry David. He knows things too. So all of them have different styles. Chris is more like my kind of style, you know, talk and charismatic and thing. These guys are a little more serious, but it's good stuff. Good stuff. So it depends on what learning style you like. Yeah, man. Blessings, Dassel. Bless up, Dylan. HSB, we could get that proper SAT program is the best in the Caribbean in the student hub. You're doing SAT, the student hub is the place to be. Guaranteed. Carry that to the bank. Kenya, Abigail. Quadratic before you go search Kerwin Springer quadratics. All right, Alia, we don't need to link this stream any longer. Hold it down. We can link.